Hello, hi guys, good morning, welcome back to a new video. In this frequency problem number 2 of today's weekly contest, which is 392. Again, problem number 3 and 4, you can see the links in comment section below. For this problem, we are simply given a string s and an integer k. As you can see also, string s and an integer k that we are given. We have to define, we have defined a function which is the distance between two strings s1 and s2 as by saying that it is the sum for every corresponding index and the sum of the minimum distance between s1 of I and s2 of I. So if I consider s1 as a string where I have, let's say, these 4 characters, s2 as a string as, let's say, these 4 characters, for every index, this is a character at s1 and s2 correspondingly. I have to find the minimum distance between these two characters, that is their corresponding distance at that index. What we mean by distance? For example, if I ask, let's say if this character would have been a and this would have been a d. So you can simply see that a distance of 3 is here. As you can see, b, c, d. So distance of 3 is here. If you do a d minus a, you will simply get a 3. If I ask you what's the distance from, let's say if I ask you a distance from d to, let's say, f. So d, e, f. So distance is 2. If I ask you the distance from d to, let's say, b, again d minus b, the distance is again a 2, which is c and b. If I ask you a distance of d and a, distance is d and a, distance is 3, which is d minus a, it is 3. If I ask you the distance between z and a, you will say Aryan 26. Is it 26, 25? No. Distance is 1 because it is cyclic, which means I can say everything as A, B, C, D, E, F, G, H, I, K, L, M, N, P, W, X, Y, Z. As you can see, distance between A and Z is 1. Distance between Z and B is also is 2. So this is how we calculate this distance between any two characters. This is how they have defined the definition of distance between any two characters. Now coming on back, they just ask us the sum of this distance. Again, this distance is the minimum distance because you can see this B and Z can have also this distance and can have also this distance, but I want minimum distance, so I will take this distance. So for all the characters at the indexes, the distance whatever I am having, I will sum up those distances. And that will be my cost. That will be my cost, whatsoever I have. So if you go and find out what I have to return, where is this gone? So basically it just says, okay, they have just represented, as you can see, A and C have a distance of 2. B and D again have a distance of 2. So the sum will be 2 plus 2, which is 4. A and Z have a distance of 1, as I have showed you earlier here also. So for every, so this is the distance which I want, and I want to minimize this distance. But Aryan, minimize distance as in, like, you are given only one string. What, with whom you will minimize? So that is one thing. I have given this luxury of k as 3, and what I can do, I know that I can go on to a distance value, whatsoever I want, character I want. So I have to change any letter of S to any other lowercase English letter any number of times, but making sure at every change the cost incurred will be the distance whatsoever I have. So if I plan to change this A, if I plan to change this Z to a Y, I will incur a cost of 1. If I plan to change this Z to a X, as you can see, Z to a X, I'll incur a cost of 2. So I will have to remove that cost from my K. So now after removing this cost, it will become a 1. Now I know, okay, I can only spend this number of distance operations, or basically this is the cost. As you can simply imagine, this is the cost of 3, and at every transformation a cost will be used. So I have only 3 coins, and I have to transform this string S to some other string. Now what that can be some other string? That string should be lexicographically smallest string. So as an output, I have to tell you, with this specific cost, I have to transform this string S to a new string T, let's say, and that string T should be lexicographically smallest. What that string will be is your question. Now, when you have got the question, let's understand how we can do it. Now, Z, B, B, Z. Before even starting off, how and in what cases the string can be lexicographically smallest? For sure, if it starts with an A, if the character starts with an A, because A is the, again, you remember, I have only lowercase English letters. I have only 26 alphabets. So for sure, A should be my most priority. If not, then B. If not, then C. If not, then D. If not, then E, and so on and so forth up till Z. So this is the priority order of the characters, which whom I value. I value A the most. Then I value B. Then I value C. So if anyway, if I have a chance to bring a character to A, I will bring on A first. If not, then B. If not, then C. If not, then D, and so on and so forth. Because this is how my order, lexicographically order will look like. So now I realized, okay, I will first have to make sure, can I bring this Z to my A? I realized, yeah, I can bring Z to a A will incur a cost of 1. Remember, I had a cost of 3. Z to a, I wanted to be a, and I was able to get a A. So for sure, I'll bring it A, my cost 1 used, again, remaining are 2. B, I will try to bring it to a A because I want. If not A, then B, I'll go on to. B, can I bring it to A? Yeah, because B to A again will be a cost of 1, which I will be using because B minus A will be a 1 distance. So for sure, again 1 cost. Okay, 1 cost. It also transformed to A. Then again B, he also wants to come to A. Yeah, he can come to A. Again, 1 cost. Okay, I'll get 1 cost. Again A. Then Z. No cost remaining, bro. What you can do? You can do nothing. Your answer is AAZ. Answer is AAZ. Okay, next character. X, A, X, C, D. Oh, you have 4. Now your K is 4. You will try. Can you bring your X to A? Yeah, I guess I can. Let's see how much cost I will need. X to A, I will need a cost of 3. I have 4. Yeah, I can bring. So I will bring my X to A. Okay, my X brought to A. A already at A. No cost required. A already at A. X, again, he wants to come to A. But bro, I have only one thing left. I cannot bring you to A. No way possible. So Aryan, okay, now I have only one cost remaining. I am at X. I have to get one thing. I realize I cannot get to A because I wanted. I cannot get to A. So will I try for B, bro? You cannot get to A. You are trying for B, which is farther than A. But Aryan, no. I can go from the back side. Yeah, that is true. You can go from the back side also. But I will say, if you cannot go to A from the front side, so you can never be able to go to B from the front side. That's a very straight point. That's a very important point. That, okay, I realized that from the front side, again, this is the front side which I'm going. From the front side, my main aim will be to go to A only. That's it. From front side, if I can reach A, great. If I have more cost, I will save that cost. But from the front side, I will aim to only reach A. Why in this world I would want to go to B from the front side? I will not want to go to B because if I am able to go to B from the front side, I will land onto and stop at A itself. Right? Makes sense? So, okay, I realize, okay, from the front side, I will only go to A. From the back side, I can go to any location whatsoever I want. I can go to any location whatsoever I want. I can maybe from the back side also, I can maybe go to A, maybe go to B, C, and so on and so forth. I can go anywhere because from the back side itself, let's say if I am at X, now my cost only remaining is 1. I remembered I cannot go to A. So for sure, there is no point in going front because you remembered your X is here. If you go on to front and you cannot reach to A, which means you are increasing. You're going in the lexicographical order, you are going in the bad side. I have only one remaining. I should go in the back side, not bad side. So I'll not go on the bad, which means the right side. I'll go on the left side and say, bro, I'll go back. So this X will try to go back from this one remaining. So he will say, okay, X can go to W. So this X can go to my W. And then, okay, everything is gone. C cannot go anywhere. D cannot go anywhere. So this is my lexicographically smallest one. Okay, last example, LOL. L want to go to A, but for sure I have no cost. I have 0 cost. I cannot go anywhere. L cannot even go backwards. A, B, C, D, F, G, I, J, K, L. K, L might have thought of, okay, maybe I can go to K or maybe before, but L has 0 cost. He cannot move anywhere. So he will remain as it is L. O cannot go anywhere. L cannot go anywhere. So this is the final string, LOL. So you realized that I will have for every character, let's say for this character, I will firstly check what is the front cost, what is the back cost for me. And I realized that, okay, front cost will look like what? How will the front cost will look like? Front cost will look like, okay, what is, I cannot do a minus x, that will be a back cost ideally. So back cost will be nothing but x, which means this character x minus a. This is the back cost. What is the front cost? Front cost will be z minus x, z, the character z minus x, and for sure one more cost to land onto 1 plus 1. This is the front cost, this is the back cost. And I want to spend minimum number of k, because it is limited k I have. I will spend minimum number of k. So I will just make sure, okay, I am spending minimum number. So whosoever cost is less. First priority is to reach to A. First priority is to reach to A. Whosoever is less, bro, can you please get me to A? That's my first priority. If I cannot get to A, then okay, if let's say both of them cannot lead you to A, so no worries. Again, remember, this is the right cost, which is z, character z minus character x. Again, you will place your character here, you will place your character c here, or basically s of I for you, and here also x minus a, x is your character, which means s of I minus a. This is your cost, this is your left cost, which means the back cost, left cost. This is your right cost, which means the front cost, this is your right cost. So now I have got, okay, if any of the cost is minimum, again, if any of these can reach you to your A, you will reach to A, and for sure you will take the minimum one. So whosoever is giving left or right, whosoever is giving you the minimum and can reach to you to A, you will go A first. If both of them cannot lead you to A, then you will use and come back. You will use your k power, whatsoever k power you have, you will use that k power and then will come back. So you will do a whatsoever character you have, whatsoever you have, let's say s of I is a character, then you will come back by k steps. And for sure, because you know that coming back is the only viable option. Going forward, you know that you can never reach A because you have already checked that. Coming back is the only option. Again, I know I will never be able to reach A, but still, I will backward, so I will be lexicographically smaller one. So I will use that backward thing. I will be at least lexicographically smaller. I will never go forward if I cannot reach A, right? So it is the only thing which you have to do, implement. What you did, that you just simply had your answer, final string. Then you went on to all the characters. Firstly, you found out the left cost to reach A from the left side. You found the right cost to reach A from the right side. Firstly, for the right cost, you will find the difference with the z and then add a plus 1 to reach from z to A. Okay, right cost you have to reach to A, left cost you have to reach to A. Then whosoever is minimum here, it is a minimum cost to reach to A. You will check, okay, this is the minimum cost and I will use that minimum cost if I can. I first have a check, okay, if my k, if whatsoever k I have, it is more than equal to my minimum cost to reach A, then for sure it is always beneficial to reach to A, where it will give you the lexicographically smallest one. So I will reach to A and I will add my A in the answer. If I add A in the answer, for sure, these many k costs will be reduced by whatsoever cost was there to reach to A, minimum cost to reach to A. Okay, k reduced, but if you cannot reach to A, then you know that, okay, none of them can make you reach to A, then you know that you have to come backwards. Backwards as in whatsoever k you have, use that k and come back. So from wherever I am standing, I'll use the k and I will come back to character. So this character C, it is k steps back from S of I. So I will be landing at the character C and I will add that character C in my answer. And for sure, as I have utilized all the k's, so I am done. My k is become 0. But Aryan, how you know that you have utilized all the k's? Because bro, if your k would have been remaining, then you would have utilized it here. You would have come back more back. You will keep on coming back. Until you can come back. As you can see, if I was at x, and if my, let's say, k remaining would have been 2, so I would have for sure went on back 2 steps. If k would have been 3, I would have for sure be able to reach A. So I would have reached A itself. If not able to reach A, then I will come back how maximum I can come back, and I will come back at that point. And thus I can simply say, where it is gone? Yeah, and thus I can simply say that my k will become 0. And this will work, that you can go front, you can go back. And for sure, as your k has reduced to 0, your answer will always be keep on coming here itself at this point, and your S of I will remain always S of I, and you will be adding S of I as S of I itself. For a simple dry run, let's dry run with this example, x, a, x, t, and 4. xa, xt, xa, xt, and k equal to 4. So in the very beginning, you will realize that your minimum cost s of I to a, that will be very high, which is because s of x is, if I number it, so let's say it is 0, 1, 2, or 26 alphabets. Okay, 1, 2, 3, and so on and so forth. This is 26, this is 25, and 20. Sorry, this is 26, 25, and 24. 25 and 24. So let's say x is 24. So I know that one thing, that my 24 minus 1, I will have 23. So I will have to jump 23 steps plus 1. Do it by yourself. So I know that this is nearly about 24. This will be z minus a. So I know that I have 26 minus 24, which is 2, plus 1. So I know I have to jump 26, which is for z, minus 24, which is for the specific character x, plus 1. So I know I will jump 3. So I know that my right is 3, my left is 24. I know that 3 is minimum. So my minimum cost to jump to a will be 3. I know my k is more than equal to 3. So I will use all that specific k. Now my k has reduced to 1. So k has become 1. As you can see, k has reduced by that minimum value, and I will add a 1. So with this, I'll replace it to 1. Okay, then again I will come back. Again, this next character will come in, a will come in the picture. As a will come in, this distance will be a 0. This also, this distance will be very high. Z minus a plus 1 will be very high distance. Z is 26, minus 1 plus 1 will be 26. So you realize that, okay, your left will be minimum. So minimum cost to a will be 0 itself, which means 0 is more than equal to 0. So you will reduce your k by 0. So k will still remain 1, and then answer will still be added to a. Okay, great. Now as x will come in again, x will come in again. So again, x minus a, 24 minus 1 will become 23. Right? Yeah. And 26 minus 24 plus 1, it will again become a 3. So you can see 23 and 3, minimum is 3. So minimum cost to reach to a will be still 3, but you have your k as 1. So it can never come to your k loop again. Now if it cannot come, what it will do, it will come here itself. Now you are at current x, which is 24. Now you will do, okay, you can go one step back. So you'll go one step back. So 24, one step back, what will be there? 23, which is w. So you will get a character which is, where it is gone, you will get a character which is w, which is 23. Then you will simply have 23. So answer, I added a w, and my k has become a 0 now because k has been used. Now again I'll go back to next character, which is c. Again I will find c minus a will be nothing but 3 minus 1, which is 2. Then this will be very large number, very large number. So minimum will be a 2. Minimum cost will be 2. Now still 0 is not more than equal to 2. So I will come here back again. Again, as you can simply see, this will be a c. My k is 0. So it will still remain a character c. I will simply add a c back in my answer, and k will again be 0, which is always be 0. And the same will go for d, and that's how you can simply solve it in O of n time. And you can see there is no space used whatsoever. You have never used any space whatsoever. So your space is O of 1. So your time will be O of n, and your space will be, sorry, O of n. Oh, your time will be O of n, and space will be O of 1, and that's how you can simply solve it. Cool. I thought this question 2 was harder than question number 3. Again, it's my view. Just comment down below what's your view on it. And all the ones 3, 4, 5, 3 and 4, you will see down below in comment section. Bye bye. Take care.